Hello.
Hey, hello there.
Good afternoon or good morning, depending on where you are.
Good afternoon here. Hello, guys. I'm Ivan. I'm one of the maintainers of Come On. I don't know if you heard about us before.
Yeah.
Hi, Ivan.
Yeah, nice to meet you. First time joining one of these calls. I have no idea what you guys are doing here, how this works, but I got a link to it and I thought, okay, let's join and see
Same for me.
what happens. Okay, cool.
Awesome. Let's wait maybe 1 or 2 more minutes to see if more people are joining, and then let's get started.
Hello.
Hi, Ted. Just saying we're gonna wait maybe 1 or 2 more minutes, see if more people are joining, and then we'll get started.
Awesome. Johannes, would you like to run this meeting? Do you have a plan?
I can run this, yes.
Awesome, great.
Good morning.
Morning, Michael. People wouldn't mind filling your name in the attendee part of the agenda. That's just a thing we like to do with every meeting here.
Okay, I think let's get started. So maybe if you don't mind, so that we also kind of get to know each other a bit, because I see there are a few new people here, also to open telemetry. That we get to know to each other. Maybe everybody can say like just 1 or 2 sentences about their background and why they are here. I think that will make then further discussions easier. So I will just start with myself. I'm Johannes. I'm working for Microsoft. I'm trying to drive this instrumentation effort for messaging, basically the semantic conventions for messaging. And I had some previous involvement in OpenTelemetry, mostly on OpenTelemetry C++. And yeah, at Microsoft, I'm working like on the distributed tracing backend.
I'm not a Microsoft person, so I'll probably chime in from here. My name is Clemens. I'm the lead architect for all the messaging services at Microsoft, which includes all the messaging services that we have in Azure. I'm also representing Microsoft in Oasis. I'm the co-chair of the AMQP technical committee in Oasis, and I'm a member of the MQTT technical committee in Oasis. In the CNCF, I'm kind of the architect of cloud events, and I've been building cloud events there kind of from the start. Otherwise, I'm kind of driving in my role as an architect, driving product strategy as well as our open source and open standards engagements.
So great to meet you. By the way, Clemens, it sounds like your microphone's like clipping a bit.
Okay. Well, I'll
Oh,
try
yeah,
and get better. Let's see whether whether the right device was picked. I'll go and check it.
Yeah.
Sorry.
No problem. No big deal. Just let you know.
So I'm Michael. I'm also from Microsoft. I'm a PM. I'm helping to lead actually the distributed tracing effort overall for the company, and trying to find ways that we can leverage W3C and OpenTelemetry libraries to reach standardization and achieve the same goals that are set out by the project. And my interest here is I'm trying to help in general with the instrumentation of trace semantics conventions to get the specs from experimental to stabilization for the betterment of the community, as well as for some of our platform initiatives that we're trying to drive for tracing.
Okay, I'm gonna jump in if nobody else goes before. I'm Ivan. I'm one of the authors of Come On. It's an instrumentation library for applications running on the JVM. We have been around for years, like, I don't know, 7, 8 years. I was slightly involved on the early days of open tracing, but got disconnected from that. And nowadays, I'm thinking, okay, OpenTelemetry went way further than what open tracing was and what OpenCensus was. And I think it's time to make these things compatible. And people using OpenTelemetry or Come On should be able to mix and match whatever way they want. So my goal is to figure out where are we similar, where are we different, and see how we can make this interoperate seamlessly. Because we have this special focus on all the like Scala kind of libraries, so akka, play framework, all that stuff, and I see how we could complement each other there. So the idea is to make it all interoperable. So I don't know what it will take to do that, but that's what I'm trying to figure out now.
I can go next. My name is Amir. I work for Spector. We're a small startup in Israel. I've been working on OpenTelemetry for a year and a half, and I wrote a few instrumentations in Node.js. The relevant ones are instrumentation for Kafka and for RabbitMQ, and I implemented the AWS SDK instrumentation with SQS as a messaging system inside it. And I read the specification many times, tried to implement it, and found a lot of issues which I would like to discuss, or we can discuss together. I'm sure other people notice them as well.
Awesome.
Hi, my name's Ken. I work for Red Hat. I'm focused on microservice frameworks with Java. So the last few years has been Quarkus, the new one we have, and I am involved in implementing OpenTelemetry for that, as well as Micrometer from the metrics side. And I'm kind of pushing the OpenTelemetry semantic conversions across the entirety of the org for any runtime we have to produce the metrics in that format, so they can be consumed and processed through monitoring and the like, and we don't have mismatches of data and names and things like that. So that's kind of where I'm coming from.
Yeah, maybe I can go next. Yeah, I'm Christian I'm working for Dynatrace, and I'm here today because I think I wrote most of the original semantic conventions for messaging, which we have now here. To be honest, I'm not really an expert on messaging systems. This was part of an effort to bootstrap the semantic conventions all together. So this was based on the data models we have at Dynatrace for tracing messaging systems, which historically come mostly from GMS. So this might explain why some of the semantic conventions look like they look today. Yeah, and I will probably mostly listen in and maybe answer questions if you have some questions why something is that way in the semantic conventions today.
Thanks.
I'm Matt. I work at Lightstep. I'm here mostly out of curiosity. I've written some instrumentation for message queues in the past. I've reviewed quite a few PRs in OpenTelemetry for them. And in general, I'm just curious if the approach that we're taking is the best approach. I sense there's better approaches that can be taken. So I'm kind of here to just kind of participate in the discussions and see what comes of them.
And I can go. I'm Ted. I also work at Lightstep. I'm one of the OpenTelemetry co-founders, so I've been around here for a while, and I'm mostly here to help facilitate these conversations. I'm very interested in getting our instrumentation into good shape now that the SDKs are getting finalized. So I'm excited. And yeah, besides just the issue of defining the conventions themselves, I'm also interested in putting a backwards compatibility plan through its paces. So we have a idea of having version schemas. And if we are going to continue to make changes to these conventions going forwards while keeping them stable, so we're not breaking people's dashboards, we need to have some way of applying, having like translation rules and being able to apply those translation rules, say in the collector. Otherwise, we'll be just kind of like stuck in stone, which is maybe not a terrible place to be, but we're about to have a bunch of discussions about potentially changing some of these things. So I'm interested in some of the things kind of around instrumentation and around the semantic conventions, as well as getting them defined. So that's why I'm here.
Awesome. I think we have everybody. So to frame this meeting a bit, we had like also in the introduction and also see in the protocol already some directions where people want to go. And just to frame this a bit, I think in this group now we have some messaging also specialists, SMEs here. So I want to just focus this discussion particularly on messaging and don't diverge too much. So there is, I think, Ivan, you brought up like a more general interest in like open telemetry, open tracing kind of compatibility. I think that is maybe best to discuss in depth in one of our more general instrumentation meetings that are not focused on messaging, because I think that is a topic that goes far beyond messaging. And I would prefer if we talk about this like in maybe a separate forum and keep to messaging here. And also in the agenda, I saw lots of great remarks from Amir that go already in pretty much like deep technical details. So I would definitely love to discuss this further, but I'm not sure if we will get to that in today's meeting, because I think the first how I want to frame today's meeting is that that we can first agree like on a goal and where we want to go with those semantic conventions, because first to give a bit of background here, the open telemetry tracing, basically we have parts of it stable, basically the API, how you create spans, how you set attribute on spans, that is all stable. But then there is another big part, which are the semantic conventions, which define how do you give spans a certain meaning. How do you say, okay, this is a span that kind of publishes a message, or this is a span who kind of consumes a message. This these conventions, yeah, we call semantic conventions, and none of those conventions is stable yet. So kind of this group is one of the first groups who tries to push a particularly part of the semantic conventions to a stable state. So we are a bit on kind of a new ground here, new and unknown ground. And I think one of the main things we need to do first is to define what should a stable semantic conventions for messaging cover. So what should the messaging semantic conventions cover so we can call it stable? What criteria do we impose there? Because I mean, there is lots and lots of messaging scenarios out there, and I think we cannot possibly cover it in version 1.0. And I think we have to kind of decide what are we going to cover, then we work towards that. And then basically we have version 1.0, which is clearly defined. And then from that on, we can iterate on and maybe consider additional scenarios. So I think that will be our first goal, to just like agree on what scenarios do we want to cover in version 1.0 of the semantic conventions. And I will share my screen here. Oh, sorry, that was the wrong one.
Too many screens.
Here we go. And I already had some very good discussions with Clemens mostly, who is here. And we tried to identify like very general scenarios that we think we want to cover, and that are kind of the most maybe important scenarios for messaging systems. And I put those scenarios here in this OTAP. And I want to start out in this group just maybe with going through this OTAP and seeing if what's in here makes sense to all of us, and if that seems like a sensible goal to work towards for version 1.0. And also, any kind of input from anybody, like when you think somebody's missing, somebody's not correct here, would be highly appreciated and very welcome.
You have the picture we drew up?
The picture here is, there is an ASCII art picture here.
Ah, okay.
Sorry, that is kind of open telemetry standard. It seems to put ASCII art diagrams into documents. But is that kind of the one you meant, Clemens? Oh, you're muted, sorry.
Yes, ours was just prettier. Is my microphone now working better?
Yes.
I switched it. Okay. Since we talked, if I may say a few words here about this. And this is also coming from a bit of background from cloud events and some discussions we've been having there, because we've been having some a tracing extension that has caused all kinds of interesting discussions around this, where we have like trace parent, trace state as an extension in cloud events, but then people were mightily confused about the role of it, and they wanted to go and throw it out. And so there's a bit of there was a bit of confusion around this. And so I'd like to, like, along the lines of that picture, if you put that up again, say a few words about the discussions that we've been having. Thank you. That we've been having, that I've been having with Johannes about this, and how from our product perspective, on the one hand, but also kind of from the standardization perspective in cloud events, we've been seeing kind of tracing play in. So there is, for messaging in general, one of the things to observe is that there is, when you have an intermediary, in most cases, not all cases, but in many cases, there's a push-pull translation, and that matters, and that's important, and that's easily overlooked. When you are doing tracing and when you are taking a look at operations and you look at this through an RPC lens, which typically happens, then everything is kind of nicely lined up on a single logical thread, because you're effectively just calling with the call flow, and then you end up at some point, and then the call flow goes back, and everything is nicely correlated. With and it's one logical thread. With messaging, that's a bit different, because there are really 3 distinct operations, or actually 4 distinct operations that play a role when you're dealing with a single flow. So there's an application to application layer, if you will, where the publisher and the consumer have a relationship, and the publisher goes and creates a message, creates an event, sends the message, raises the event. And then there's a consumer which goes and takes that message and then does something with it. In that relationship between the publisher and the consumer, very often, if you look at this from an application perspective, the application is abstracted from the underlying messaging infrastructure, which means it doesn't care how the message got to it. And very often these days, the push-pull translation that happens, so you send into a queue and then you pull from that queue, is again reversed on the receiver side or on the consumer side, and then turned into kind of a reactive flow. So it looks like there's one logical thread, but there's stuff happening in the middle that's abstracted away. But mostly those applications, the application context doesn't care. The application context is mostly concerned about itself. It is like the app over here does something, the app over here receives something, and it acts on it. And what you want to see in the trace is really the application to application concern with none of the goop in the middle. That's the top layer. And when you talk about an event-driven application, you will often think about that relationship. You will often think about the publisher and the consumer without really worrying about the messaging infrastructure that sits in the middle and the details of the messaging infrastructure. But sometimes that does matter. So the more involved you get into into message handling, and there's a bit of a difference here between eventing and messaging, which means job processing and reacting to pub/sub events, then your relationship to the messaging infrastructure somewhat changes, and also your interest in the functioning of the application infrastructure, the messaging infrastructure changes. So there are several acts here that matter. The producer, so what I just talked about with that relationship is number 1 and number 4 in this list, right? The producer creates the message, then that somehow gets to the consumer, and the consumer processes the message. That's the application level relationship. Then there's an act of publishing. So the producer publishes the message to an intermediary. That might work the first time. That might fail the first time. Then you might go and retry that operation. Retrying that operation may will cause new information to be created. There will be an error that you have to go and trace. There will be, the retry may cause a back off, and the back off will be impacting latency. There's all kinds of things that even if there's magic that's happening under the covers, will be something that will be interesting for diagnostics. So the act of publishing that message is something that is an operation which is already separate from the flow that the application, kind of end-to-end application, is interested in. And that is because if the message can ultimately be published and it can ultimately be received, then for the overall application flow, everything is hunky-dory, everything is wonderful, right? Just for the particular fact, the particular zoom in of application infrastructure piece, you're interested in what happened wrong, why did the publishing take so long, and that is because there were a ton of retries, and you then find that because of the ton of retries, there might be a networking issue, there might be something else that happened. So there's this first extra, the new context. The interesting thing is that that new context derives from the original context. The cause of the message being sent is the same for the end-to-end relationship between producer and consumer, and for the send operation, and the next send operation, and the next send operation, which ultimately succeeds. All of those are caused by the same reason, right? But they're separate operations. Now it gets even more interesting. Number 3, the consumer receives the message from an intermediary. There's an operation that starts without you knowing what's going to happen, because you start receiving a message, and that's an operation that's worth tracing, and that's worth, investigating if that doesn't work. But you're not doing that anticipating a particular message to show up, right? And therefore you don't do this anticipating a particular context to show up, which means you have a new context that's being created, and that is the intent is to go and receive a message, and then you are effectively picking up a context based on the message that you just got. So that's the second extra operation. Once you have that context now, you are now working on that. You're now working on that message. You're now processing it. That is number 4, right? Number 4, the processing of the message is effectively linked up to number 1, producer creating the message ultimately. And now you have and then number 5 is you have now processed the message, and now you're settling it. And settlement is something that is really important in messaging, and that's something that doesn't really show up in any of the other environments. Settling means that the outcome of the processing is now reflected in the delivery state of the messaging system, meaning the processing of the message did work, and you are interacting with the queue. Then if the processing of the message worked, you want to have the message removed from that queue, which means you're going to complete it, or you're going to settle it. If the processing did not work, you will go and abandon the message so that it can be represented, so redelivered and reprocessed. If the message is faulty, which means you know that the message will fail again, you will reject it, which will cause the message to be dead lettered. And so those are the settlement modes, effectively, if you're interacting with a queue, and that's typically true for most queues that you have those mechanisms. If you're interacting with the stream engine, you will, so the Kafkas and Pulsar and Venthubs and Kinesis, you will not individually settle messages, but you will basically just decide whether you want to go and advance the cursor that you're managing on the client. And then if you are deciding not to advance the cursor, you're then going to go and reread and then effectively reprocess the message based on that. So, but that's kind of the various different contexts that we have identified. And we have, unfortunately, on the slide, so one thing that's a bit missing from the picture here is that you have these combinations of contexts in the pretty slide. That's kind of missing here.
I will put this slide up next time.
Okay. So that's kind of what we. So this is, I think that's a summary of where we were in our discussions. Is that there are actually several different tracing context or context scenarios that are kind of arising out of the interactions with a messaging intermediary, which are caused by this push-pull translation first, because when you're receiving, that's a tracing operation, but then you're just picking up a context that you don't know about first. And then that message settlement is something that is a very unique interaction with the messaging system that is dependent on the outcome of the processing operation, which also needs to be effectively reflected in the traces. And then, of course, that there is a difference between publishing, the act of publishing, and the message creation, where the application per se will only care about the end result of the delivery, while the someone who's trying to find out why stuff took long or why something is stuck will go and go a level further down and go and try to investigate why the publishing didn't work. And then the last thing, what we see more and more on the messaging side is now that we have replication routes, so that these interactions are no longer just go to a single queue and then get the message from a single queue, and that's kind of the application view. But we're now getting more complex systems where you're publishing an event into an event broker, and that event broker then goes and propagates that message into another event broker, another event broker, another event broker, or a queue. And then you have an end-to-end relationship between a publisher and a consumer, where you have three brokers in the middle, which are immaterial and actually invisible to the publisher and the consumer. And that's something that the publisher and consumer don't know about. But then you have kind of these three infrastructures, which might be managed by different parties, which are then observed separately as those messages pass through. And still, the individual message that's being sent carries a context which effectively you need to be able to refer to in all of those intermediaries. So that's why the mother context, if you will, right, the original context that comes out of the original message kind of always plays a role in all of these daughter contexts, if I may call them like this, that are then kind of related to the publishing, settlement, republishing of all those other messages. And here I will stop.
Thanks, Clemens. That was great. So as you can see, Clemens helped me a lot coming up with this diagram here. So just to maybe summarize what he said in very few words of a non-messaging expert like I am, I think we have here the two very high-level stages of creating a message and processing a message, like creating a message on producer side and processing a message on consumer side that you can see from a very, very high level. And then there's all the work basically that the message broker does in between. And then with this, we get those additional stages like publishing, receiving, and settling. And those all kind of talk with this intermediary in between, so that the kind of you can see as maybe a layer below this very top level layer. And I think when we define how we're gonna how the traces for this scenario should look like, I think it makes sense for us to keep those two layers in mind. That those are kind of those two layers is kind of slightly separate in mind. I mean, yeah.
So Johannes and Clemens, is the intent that so for the case for time spent in queue, that we want the spans to represent each one of these layers, so that would we have to be issuing multiple spans, or would it be a single span that represents all of them? That's what I'm just trying to understand a bit here on how later when it gets stitched as a trace.
I think we're not talking about traces exactly yet. I think that's a later discussion. I think we're just trying to get the same conceptual model here.
Gotcha.
We will talk then. Once we agree on this model and once we agree on these scenarios, we can then get into talking about how we really want to model this with traces.
Okay, and then one last question was that on the settlement part, Clemens, is that asynchronous in nature? And the part I didn't get is if it fails multiple times, at what point do you just say, I'm not going to settle and I need I'm just going to drop it?
Yeah, so the way how message brokers do this is they will silently drop that message into the dead letter queue and don't tell the application about it. So the way how there's a concept called poison messages, where a message that gets presented to an application, and there's something wrong about that about the message, but the application doesn't know or doesn't understand it. It keeps throwing. Because there's something that there's a bug. There's either a bug in the input or there's a bug in the processing. So the message is going to be shown 4 times, 10 times, and it will always crash. So in that situation, there is a max delivery count, and that's implemented in most queue brokers in some fashion, which will, if you exceed this, then so the deliveries are being tracked by the broker. And then if you exceed this, then the broker will go and take the message out and just drop it into a dead letter queue and say, sorry, that didn't work. So effectively, there is a, and that will often be annotated with a reason code. So you will find a message in the dead letter queue, which has a trace identifier, if it's annotated with the trace parent, trace state, where you can then effectively see the message coming out of the dead letter queue. And that's a path that you then need to kind of have also kind of part of your diagnostics infrastructure. You can also peek it, and you can go and browse it, and that's typically possible with all the brokers. But you can see the delivery count being exceeded up to 10, whatever, and then you can also see the context being annotated on the message in metadata.
Gotcha, makes sense. Thanks, Clemens.
And of course, with every delivery, and this is where we get into the details of what is the stuff that we need to go and catch from the message metadata and having the log in the derivative events, as I would call them, to make sense out of those things. So you would probably, the delivery count is for queues is something like you get a message, what is the current delivery count, is something that's a important piece of information to kind of then eventually find out what the journey of that message was.
I have 2 points maybe about this model when compared to, for example, HTTP or any other semantic convention. I wonder if the create versus publish step is something that is so special to messaging. For example, I could say to produce the HTTP request, the logical data I want to send is a separate step from actually calling into my HTTP client library. So I'm wondering if the create step is actually something we want to count as part of messaging semantic conventions, or if this is something that is just some general application span. This is one point.
So for anything that's networked, for anything that's networked APIs, there is a so maybe I'm now kind of getting into the broader story here, but anything that's a network API can fail, and pretty much all the libraries we have now have some notion of automatic built-in retries. So if you have an HTTP client, you can go and you formulate an HTTP request, and then you start sending the HTTP request, and then if that doesn't work for some reason, it'll try again. If that's true, then the second delivery and the third delivery is something that obviously needs to be tracked separately, right? So but for the application, and this is the distinction that this distinction I'm making here, right? For the application, the fact that this built-in retry policy did some magic to make sure that the message actually got over there doesn't matter, because for the app, the only thing that matters is like it all depends on who you are, right? If you are the application developer that only cares about, I have a request and there's something that arrived, then you don't care about the retry policy having done stuff, right?
Yeah.
But if you're now down and you try to figure out particular error scenarios, then you care about that. But ultimately, depending on your role relative to the stack, you might not care about particular things that are happening with that message. So I think that what we have here, that separation, is something that's just as applicable to HTTP, because ultimately the difference between HTTP and this is always the consumption path, right? When you think about messaging, right? Messaging is MQTT, AMQP, Kafka, Pulsar, Google PubSub, SQS, whatever the systems are, and some of them do that over HTTP. And the send side is always the same thing. Take a message, take a frame, transfer it over, make sure it's there. Thank you very much. They're all different in consumption. And so the consumption model is what's really ultimately the distinction. And that's how the settlement piece comes in here, which is really and then of course the explicit step of pulling, because in HTTP, in reality, you're also pulling, but you're pulling from a socket. And so that pulling is something that kind of goes away in the HTTP listener, and that's kind of so far down in the weeds that you don't care. But here, with interacting with the messaging system, receiving is an explicit act, and that's why it's called out.
Yeah, that's kind of what I also understood. So the creation, the producer side is not that fundamentally different on a fundamental span relationship level from other semantic conventions.
Correct.
So I was wondering, since the scope is already probably quite big, if this general retry handling, and I think that's what this is mostly about, the complications on the creation and publish side, should maybe be mostly discussed in the other semantic conventions meetings. Except maybe if it is interleaved with the other side very closely, then of course we need to discuss it also here, but otherwise this would be maybe an opportunity to reduce the scope a bit.
There's metadata you care about.
Mm-hmm.
So the difference, I think, is will then lie in the kind of metadata that's related to that operation. Because as you are publishing, there is information that you may want to see in the log messages, right? And that is interesting for you. I don't know. So I'm actually not as far in so I'm not the expert I'm the messaging expert. I'm not the logging, tracing, everything expert. So wonderful, we meet here. One of the things that I've seen in the draft, in the existing draft, was that there were quite a few metadata items that were called out. Right, so some Rabbit, some fields from Rabbit, and some fields from Kafka,
like the message ID.
Exactly.
Right. Yeah. I think in open telemetry lingo, I think we call these attributes. What you're calling metadata, right? Just for clarity.
Yeah, we call them cloud events. We also call them attributes, but they're called properties here and metadata here. And metadata is kind of the collective term for those. So I think so it would be good to have a generalized notion of the distinction between making a message or creating a job, a call, and then trying to get it over there. Yeah. Because I think those are two distinct things, and having a generalized notion of that will probably be useful.
Yeah.
But then for the various transports which are messaging specifics, MQTT, AMQP, Kafka, etc. It'll be interesting to then go and have particular bindings that enumerate key elements for how you want to represent them, and also having a discussion about what is really the stuff that we want to go and standardize, because ultimately there is something that, independent of what the transport is, will be what are the fields, what are the 3-4 things that we want to definitely see in any tool, no matter which proprietary transport it uses. So do we have anything? Do we think that every message has an ID, right? Do we think that every message has a timestamp?
Yeah, this was actually a question that I had as someone who's, I mean, I've used messaging systems, but I wouldn't call myself like the expert in the room. But for you all, the experts who know how a lot of these different systems work, is it feasible to what degree is it feasible to have a general model, like a generic model of messaging that we then shoehorn all of these different messaging systems into? Like, are they all actually similar enough that conforming to a general model is helpful to an operator? Because the end user of this tracing data ultimately is an operator who's trying to debug a Kafka system or an AMQP system.
Yeah.
And and it's a genuine question. I don't know what the answer is. Like, to what degree does making like a generic model, like what we've seen elsewhere is generic attributes are helpful in the sense that someone can add a new system, and backend tracing systems, analysis tools can automatically perform something useful on that system without knowing anything about its specifics, because we have this generic model. But then the tension that you hit is if these systems really do diverge in how they work, and they also diverge in terminology and in other ways, the more you try to shoehorn into a generic system, a generic representation of a messaging system, like the more that operator is trying to now like look through an extra layer of abstraction in order to understand what their system's doing. So I'm curious. I mean, I think we'll get into the weeds of this, but that's an area that I'm just curious about, is like, where do we draw the line
we're
there?
Get in the weeds of this.
Yeah.
So this, I believe this model. So I believe this model is representing generically most of the common messaging systems that are out there, from all of those that do this push-pull translation. There's another class of messaging systems which I've kind of, we kind of scoped out, like the AWS Event Bridge or Azure Event Grid or Knative Eventing. Because what they do is they basically, you publish an event in by push, and then those systems push them back out again. So they are effectively a ultra powerful webhook caller, right? They're effectively like what we just discussed as retry policy, right? Is something that those kinds of eventing brokers do on the server side. They are a server-side retry policy engine, if you will, right? But there's a clear flow that is obviously from here to here, end to end, without any of these settlement things, because they push. So that's why we kind of left them out. Yes. So in terms of, I think in terms of how generic and how specialized things can be, we've done work in cloud events in particular, to try to find, at least for events, a minimal set of metadata, a minimal set of attributes, which kind of all events need to go and follow. And actually, I think cloud events might be an interesting, and that's a meta point, right? Cloud events might be an interesting mechanism to also standardize how log entries look, because log entries are nothing more than cloud events per se, right? So that nothing more than events that you capture. But what we did in cloud events is to basically say, what is there in an event? What do we need? And so there's a type, there's an ID, there's some time, and then there's a source, and there's a subject. So we have like 4 or 5 attributes that we have. And then what we've done is we took those attributes and we kind of mapped them onto constructs that are existing in the various transports, so MQP, MQTT, Kafka, HTTP, etc. But kind of from that exercise, what's clear is that there is no clean mapping. Like if you go this direction, you kind of start with an information model, and then you go into the various transports, you can always find a good place for any of these information items, right? But if you're coming from the reverse, if you say, I want to go and inspect an MQP system, or I want to go and inspect the Kafka system, then you really are coming from the opposite direction. You're coming with, you can't make any rules around, what the structure ought to be, but you really have to live with the stuff that's there. So I think you can't get around the unfortunate lack of standardization in this, lack of standardization aspects of this area, and deal with attributes and metadata kind of on an individual basis.
Yeah.
Good news is that standardization does exist across quite a few brokers. So there's, as I said, MQP, MQTT, Kafka is something that is kind of sort of standard, or Pulsar. At least there's large OSS projects, so that even though the space still has issues with standardizations, there are not so many products that it becomes impossible. And because the models are still very closely aligned, there are not so many patterns in messaging. I think the complexity of making those bindings will be manageable.
Yeah.
I also want to answer Ted, to your question, because I think it's a good point. But when we look at existing semantic conventions, I mean, also there we have some rules there buried that said, okay, this bands has to be parented, and those bands have to be linked, and those can be parented again. So I think already in the existing semantic conventions, we have kind of a model like this underlying.
Yes.
It's just not made explicit. It's just implicitly there somehow, and I think whatever we do now with a stable version, I think if we have this kind of model underneath, and I think we need some kind of rudimentary model to define how spans should be linked and parented.
Yeah,
I think we should make this model explicit.
Great. So like we have this in HTTP, for example, and we're trying to flush it out, and it matches a lot of what you're saying, where people want to see like a logical HTTP span representing like a logical HTTP client. And that's like very useful to have one span with all of the indexing on it, all the attributes on it, recording the overall total request time. But then under that, you have child spans that are representing the kind of mechanical HTTP requests, where there might be a bunch of retries and redirects and other stuff going on. And so you need to have that kind of model. I think where we've been kind of like on easy street with the other things we've been defining is they are like tend to be very well defined protocols. Like HTTP is like the HTTP protocol. All the implementations are the same. And then with database stuff, it's like SQL. And it's true, there are different flavors of SQL, but SQL is still like, a protocol and a language. So it's the database specific extensions you get into are more like different attributes, but the fundamental shape of what's going on in a SQL client doesn't really change. But when we started to talk about generic database attributes, and now you're trying to like shoehorn SQL and MongoDB and like other things into the same model, that's where it started to get a little weird. And so I just suspect over here, we're gonna probably be wrestling with that problem more than we've had to wrestle with it in other areas, because there's just more divergence over here. And while it's true that there is like a generic mental model, and if I am an application developer trying to architect my system, I would want to architect my system against a more generic model and maybe not try to rely too much on the specifics of an implementation. But if I am an operator, who's our audience, I'm trying to debug the system I have, that operator is always going to be debugging a Kafka system or debugging an AMQP system, because that's what what they happen. And so that's like our particular audience. Like you see what I'm saying? You still have like, I'm not saying you wouldn't have these like logical operations like you're describing them. It's just we should maybe make sure we really exercise this stuff to ensure that we're hitting the kind of model that the operators are going to be consuming this tracing data want, as opposed to maybe application developers who are trying to architect their system. Like they're kind of not appearing in this film.
What makes things a little the extra complication. So if you say, so there's wire standards, and then there's API standards, and how the application interfaces with stuff is always differs. And where we slot in tracing is obviously in the code and not on the wire. Which means the APIs is kind of an interesting place to go and hook into. So in messaging a particular, and I need to be mindful of the time, in messaging a particular API that's super successful is JMS. And so JMS gives us a way to do first a hook, and then second has common semantics. But that's only true for queue-based messaging. It doesn't work for streaming. Kafka has a common API, but then that is very specific to the Kafka broker, and it doesn't work with many others. So I think we will have to go and find and then AMQP, just another thing, right? You might quite well have the situation that you have an AMQP application which is generic and works against ActiveMQ, but also works against Azure Service Bus, right? So you basically just go and switch them around. So there's some middle ground here, right? The way I'm thinking about this is that we might end up in a place where we have a set of common attributes that we then backfill with bindings, so that because tooling also needs to have commonality of sorts, right? You want to go and deal with a queue, or you deal with a stream, and then the tool also needs to have a way to go and have a generic representation of what that queue thing is. And so that we have a set of common attributes that we can always map to and from those products, and to and from those APIs, where you then have extensions where you can go and effectively you can double click. And then if you really want to see how this thing looked in all the details of AMQP, then you can go and double click in the tool, and you can kind of get all that data kind of in its raw form without specialization, without having a generic.
Yeah, this is exciting stuff. I think I may need to call time just so people know. We only have 4 Zoom meetings for all of OpenTelemetry, and this airspace, this kind of time slot, they all get used right after this. And so if we don't get off the call in the next 2 minutes, then people for the next meeting are going to start piling into this one.
I need to go to a CNCF meeting right now, so that's all good.
Yeah. But we should continue this on Slack, I should say. And yeah, Johannes, if you want to play us off.
I'm going to wrap up then. So firstly, thanks all for participating. We are planning like next Thursday at the same time to continue this discussion in person. In the meantime, please comment on this PR that is open here. It's linked in the document. Also, there's a Slack channel of Tel Instrumentation where we can continue any kind of discussions. So yeah, please comment on this PR. I will also then from the recording kind of recap some of the discussions and try to capture that in the PR so that other people can follow up. And yeah, thanks all. That was a great first kickoff, and I hope I see many comments on the PR, and I hope I see you all again next week. And hopefully next week we can move on from this diagram to talk about like particular scenarios that we have here, and maybe this will also help us to kind of discover gaps that we might have here in this model if you can come up with scenarios that are not captured by that.
Yeah.
But yeah, awesome. That was great. Thanks all for showing up, and hopefully see you next week.
Thank you.
Thanks, everyone.
Thanks, everyone.
Bye.
Bye.
Hey, John, you there?
Yeah, did you all hijack the Java instrumentation meeting or Java SIG meeting?
Well, I realized I linked on the click for the Java one an hour earlier. So I was in a meeting where I actually didn't intend to be to begin with. So
I think we should both log out of here so we can get the recording reset because it will
okay.
match together. And I gotta tell everybody that we need to bail out of here.
Okay, I'll leave and then join again.
Cool. Trask and Tyler, we need to bail out to get the recording reset.
All right, going. Bye.
Bye.